This video is part of a series of video instructions on the BioGrace greenhouse gas calculation tool. This is instruction 2.12, the Calculate Efficiency sheet. Actually, there are two BioGrace tools. There's BioGrace 1 for biofuels and BioGrace 2 for electricity, heat and cooling from biomass. The instruction will show the BioGrace 2 Excel tool, but can also be used for BioGrace 1, as in the BioGrace 1 Excel tool the calculations are made in exactly the same way. Whenever a boiler or a CHP is used in the process of a bioenergy pathway, information on the thermal and/or electrical efficiency is needed to fill in the general settings box at the top of the pathway sheet and for making actual calculations as part of individual steps in some of the pathways. For instance, in the step pellet production in all pathways in which pellets from wood, straw or bagasse are produced. The Calculate Efficiency sheet aims to provide this extra information. Please note that in case calculations are made to demonstrate the sustainability of bioenergy and the calculations will be verified, for each separate boiler and/or CHP used in a pathway, this sheet should be duplicated to keep a record of the calculations made. This will facilitate the work of the verifier that will verify the calculations. This video instruction will present a step-by-step description of the use of this sheet by showing two examples. For more information on the calculation rules related to the Calculate Efficiency sheet, please have a look at the document BioGrace Calculation Rules. In these examples, we will work with the pathway pellets from forestry residues. The first example is on the final conversion of wood pellets into heat using a wood pellet boiler. The second example is on pellet production from forestry residues with heat provided from a CHP on two different fuels, wood chips and fossil fuel oil. In this pathway, there are two places where you need to fill in an efficiency in case you make an actual calculation. The first one is the thermal and electrical efficiency of the CHP during pellet production. The second efficiency is the efficiency of the boiler or CHP converting the wood pellets into heat and/or electricity. Let's look into the Excel sheet now. I will show both examples. As you need to use the calculation efficiency sheet twice, you should make a copy of this sheet like this. Let's first look at the wood pellet boiler at final conversion of the wood pellets. To calculate the conversion efficiency, you first fill in the annual input by filling in 4 pieces of information. The type of input fuels here, the weighted average lower heating value here, the amount of fuel here, and the moisture content of the fuel here. After filling in this information, the amount of energy is automatically calculated, expressed as megawatt hour down here. The second step is to fill in the description of the annual output like this. To calculate the net electricity and/or heat produced, information on the gross energy production and internal use of energy must be provided. For calculating the efficiency for heat production, as is explained in the next step, information on the average heat quality in degrees centigrade should also be given, like this. The results on efficiency of electricity and/or heat are automatically calculated and provided at the bottom of the sheet here. Finally, you should copy the result, which is a thermal efficiency of 88.7%, into the relevant pathway in a general settings box like this. The second example is on the thermal and electrical efficiencies of a wood chips CHP in the production pathway of wood pellets. I have prepared an imaginary example which is more extensive for two reasons. In the first place, there are two input streams, including a fossil fuel. Of course, not all heat and electricity produced from this CHP will be renewable heat and renewable electricity. However, the CHP will have one thermal and electrical efficiency, which we will calculate here, making the assumption that the efficiencies are the same for all fuels used in the CHP. In the second place, the example is more extensive as heat is produced at two temperature levels, which could, for instance, be both heat for the pellet production itself and heat used for industrial processes. Because of the two heat levels, the overall thermal efficiency of 40% is made up of two thermal efficiencies, one for each heat level. The thermal efficiency for the heat at 145 degrees centigrade is 25%. The thermal efficiency for the heat at 285 degrees centigrade is 15%. I will not further explain the numbers. You might want to pause the video instruction to have a better look at the example. Also, these outcomes can be transferred to the pellets from forestry residues pathway that we already filled in for the final conversion step in the first example. In most cases, you will have one electrical and one thermal efficiency. Now, first fill in the correct pathway configuration by selecting the way of heat provision in the pellet production, using the drop-down menu here. In this case, select wood chip CHP in an actual calculation. Then scroll down to the wood pellet brick production module in this section here. Here, fill in the calculated total thermal efficiency and the electrical efficiency of the wood chip CHP. Then select the option that heat is usefully used at two or more temperature levels with this drop-down box here, and indicate that the wood chips are not dried here. Further down, you can fill in the two temperature levels of the heat produced with the corresponding thermal efficiencies. A check for consistency of the thermal efficiencies is automatically carried out here.